Hello everybody and welcome back to the bench. As you can see, we have another nice headphone amplifier here. Should drive your headphones to some pretty nice volume levels. Anyway, what we have is a Peavey model CS-1200x, advertised as 900 watts times 2. And this is, of course, a commercial sound amplifier. This is not something you normally would put in your living room. It's designed to be rack mounted, and these are used a lot with pro sound, like in DJs, or used in racks for live performances and so forth. And I picked this up at a flea market. I think it was 20 bucks or something like that. So I'm not expecting it to be working. Haven't plugged it in, haven't tried it, anything like that. But I thought this would be a change of pace here from some of the other things we've been working on in the past. So obviously I'm probably not going to plug this in right away until I see what's inside. You never know if this thing's been dropped or if there's anything loose inside or what shorted out or whatever. So we're going to get the covers off and take a look inside first and see what it is we find. So if this sounds like an interesting video to you, stay tuned, and we'll see what kind of trouble we can get ourselves into. Alright, I have this thing partially apart. I thought I'd pause here and kind of give you a little show and tell of the inside. The first thing you'll notice on this side, this is your power supply. Two massive transformers. I mean massive. This thing is heavy. I bet this amp weighs upwards of, I don't know, 60 or 70 pounds. Very heavy. Great big capacitors down in there. But on this side, this is your amplifier side. And to get it apart, there's a bunch of hex head screws here that come out. And then you kind of have to, if you notice these pins up here, these are actually connector pins that plug into the actual preamp board. And you kind of have to wiggle it up and out, and once you do that, it just kind of swings over to the side, just like so. And you can see just how unbelievably filthy this amp is. So this amp has had very heavy use, and it is certainly going to need really cleaned out really well. So basically this thing comes apart in sections like this. And it's not something that you can just take apart in 2 minutes, obviously. So we're going to kind of clean this up and everything. I don't really want to turn it on until we clean all of the crud out of here and make sure there's no dead shorts or anything burned up or anything that looks really bad. I'm going to do some spot checks of the transistors and check these current limiter resistors. Make sure there's nothing blown or anything like that before we even start to try to plug it in or anything like that. So that's the beginning of it, and once we get things cleaned up a little bit, we'll be right back. Okay, we finally got this thing all apart, and I just went through and did a very thorough cleaning on it, so I kind of want to stop here and catch you all up. To get this thing apart, it looks really, really difficult when you first try to take one apart. But actually, this thing is put together in modules, and once you kind of understand how they do it, it's not too bad. Unfortunately, I did a search online, and although there are a lot of operating manuals and just individual schematics for these amplifiers, there's no official service manual, at least posted, that I could find, even for purchase. It seems like it's something that Peavey only gives out to their authorized service stations, and it looks like it's pretty closely guarded secret of some sort. Again, maybe some of you may have one or may know where there is one out there somewhere, but I was unable, after a little search, to find one. So I kind of had to figure out how to take this apart myself. But to do so, it's not too bad. The first thing you need to do is, this is the rear of the amplifier. This is the front over here. And if you look, the whole back plate itself, and let me back the camera up so you can see it. The whole back plate is just one full assembly, and it has all of the input and output connectors and so forth. And to get it out, the first thing I did was I just removed the fan, which attaches right here, 4 screws. And then, as you can see, all these little screws here, they all attach to the rear frame. So you have 4 screws here, and then you have the screws down here in the power supply. They all come out, and then a whole bunch of screws along the bottom. And then this whole back part comes out, and the only connections you have, and I haven't cleaned this yet, this is the only part I haven't cleaned, is you have your speaker terminals here. You know, there's one, and then there's the other 2. So you have your right, left, and common. And then you have one smaller connector here, and then you have 2 other connectors right here. And take those off, and the whole module comes out, or the whole rear panel comes out, and you can see up here is your connectors for that. And then once you get those undone, there are several screws in the front, and you can see here, this is the front of the unit, and they attach to these 4 holes here. And you can leave the potentiometers in. They mount right here. They'll come out with the chassis. I moved them out because I took these boards out to clean them. More about that in a second. And you take those 8 screws out of the front, and the whole amplifier module comes out, and they actually put a nice umbilical cord here that allows you to remove the whole amplifier module. You can turn this up on its side like I have, put this kind of in front of it or beside it, and then it kind of lets you work on the amplifier out in the open. Now, to get the amplifier modules themselves off, you have these hex screws right here, and you'll see there's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Take those out, and then this whole module will just swing out on this one little cable bundle, and it'll allow you to get to all the components. Now, I cleaned it all thoroughly, and I just did a static check of all the transistors, compared the 2 channels, and at this moment it does not appear that any of the transistors are shorted. I also checked all of the current limiting resistors on these boards. They don't seem to be opened or damaged. You could see where they got a little bit warm, but I would expect that with a high-powered commercial amplifier like this, so you're going to get that. So really, this amp module doesn't look too bad right now. So I'm kind of a little more confident that we can try to power this up on a dim bulb. Now I'm going to leave these disconnected right now. This is just going to the back panel, and really none of these should matter. We should be able to power the amplifier up without the rear panel plugged in. There's nothing in the rear panel except input and output connectors. So worst case scenario, I mean, you wouldn't get sound, but it should power up. So let's do that. I now have everything kind of positioned in such a way that I can see it all. I have all the wires separated so nothing's shorted. Just keeping everything out away here so we don't have any problems. And check this. Okay. And all we're going to do is I have it plugged into the dim bulb tester. So up here you can see I have my bulb. And as long as nothing's shorted, this bulb should light up very brightly at first. Because you can see down here you have a bank of 4 large filter capacitors. And each set of 2 goes to 1 transformer. So the way this amplifier is powered is there's 2 independent power supplies. One for the left channel and one for the right channel. So they each have their own transformer, they each have their own capacitor bank, and they each have their own rectifier. It's 2 totally separate, so it's a dual power supply system. So this thing, as you can imagine, can deliver a large amount of current. So if everything's good, these will energize. These should charge up and make the bulb very bright at first, and then the bulb should somewhat dim back down. If that's not the case, then it indicates that we have a short somewhere. So let's flip the power switch on. I'll try to get the bulb in the shot here and we'll see what happens. And you can see, yeah, we have sunshine down here. And you can see it's not going down. It's full brightness, and the bulb is not dimming at all, which means that there is a short somewhere in the system. So now what we have to do is try to narrow it down. Is it the amplifier or is it the power supply? My guess is going to be power supply only because none of the big power components in the amplifier seem to be shorted, and all of the static resistance measurements between left and right channel match. As far as when I measure across the transistors and so forth, nothing seems to be different from one channel to the other, because there's two of everything in this amp. So that's why we're troubleshooting it this way. This one board is your preamp and driver board for one channel, and then on the other side you have the preamp board and so forth, and you can kind of see it for the other channel. So it makes it really easy to troubleshoot because you can compare one channel to the other. So first thing we're going to do is check for power. So now we're at the point where I need to print out a schematic. I'm going to print out the schematic, and then we're going to kind of go through and measure our voltages. Okay, we're now looking at the main power supply on the schematic. And let's go over a little bit of how this works. So here's your input, your AC mains coming in. And if you notice right here, this is actually a little switch. And it's kind of unique how this works. This switch represents the on-off power switch on the front of the amp here. When I toggle that switch on, what you're doing is it's not turning the power onto the transformers. It's actually sending power, if you look, up through here, through these two thermal switches. Okay, so each heatsink pair on the right and left channel has a thermal cutoff switch. So it has to get through those. It goes through a little dropping resistor, and then as you see here, it goes to a triac. Now don't confuse this with our Carver videos. This is not a magnetic field power supply. This triac is literally acting as a switch. So what this is doing is it's allowing a small switch to switch a large amount of power. In other words, if you wanted to be able to turn these great big transformers on with a normal toggle switch, the wires would have to be massive and the switch would have to be massive, and even with a large switch, the inrush current across that switch would be so great that it would actually damage the contacts of the switch. They would be arced up after a while. So this amp, remember, is built for heavy-duty, long-term use. So if you notice, these wires here are very tiny. And the reason they are is all they have to do is provide power to the gate of this SCR. This SCR, in turn, will then take the power from this leg of the mains, your hot leg, and you can see part of it goes up through this end and part through this end. Now, there is a little bit of a modification from this schematic. They're showing 10 amp slow blow fuses, or 10 amp fast blow, I'm not sure. They don't say. In this particular one we have here, they're using 7 amp slow blow circuit breakers. But other than that, it's the same. So the first thing I want to do is I want to make sure that this triac here is in fact getting turned on. And in order to do that, I want to measure my continuity from here through these thermal switches out to this resistor. Now, if you look, here is our triac. Here's one of those wires, and if you look over here, and I'll move things for you, you can kind of see there's one thermal switch, there's the other thermal switch. They're wired together through this bundle over here. It comes around and out into here, and you can see one end of it coming off the board, and then the other ones are down in here, and I'll have to get way down in there to check it. Now this is a little bit tricky to take apart if we have to tear it apart to that point. I'm going to try to just get in there with my ohm meter, and I'm just going to ohm out the whole loop to there to make sure it's good, because I have a feeling that this is not gating. Okay, I removed one of these breakers here from here and disconnected it just to get a little better access to those wires, and I pulled them up off of the terminals of the board, and we have, these are the two wires from our thermal sensors, so we're going to test those out, and we'll go from here to here. Hope you can see this, and as you can see, we have continuity, so we do have a signal all the way to the 4K resistor. Okay, scratch that. That was not a 4K resistor. It's a 22 ohm resistor, and it's buried under here. But if we touch the one terminal down here, I think, right here, and we touch the one up here, there's our 22 ohms. And you can see that's this, where are we at? Right here, 22 ohms. So we have continuity all the way through here and up through here. So for some reason the amplifier is not getting the main power. Now the reason that's right there, we need to stop there, is because of all the safety and everything in here. These transformers will power up as long as there's power at this gate. This will turn on and it'll power these two big transformers, and I should have my plus and minus 86 volts on both sides, and I am not getting that. So right away I'm kind of suspecting maybe that the triac may have failed or something. So let me look at it a little bit closer and we'll be right back. Okay, I have removed the triac from the circuit. You can see I just disconnected it in there. And we go back to our dim bulb. If we flip the power on, as expected, there is no light. So even if the triac were shorted, it wouldn't matter. It would just make the amplifier turn on without the power switch. So where we're looking at now, our next step is, I'm going to suspect that one of these bridge rectifiers may have something going on with them. And again, since we're on the dim bulb, we're not blowing any breakers or anything like that. I don't want to do that because I don't want to damage anything. So we're going to disconnect the legs from these and see and reconnect our triac and see if we get power out of the transformers. Okay, we have our two main plus and minus 86 volt high energy bridge rectifiers disconnected and very precariously floating in the air. You can see there's the one wire disconnected, the other down there, and then down here you can see the two right here that are disconnected. So now the only windings that are connected through the triac and through the transformer would be the ones that power our low energy power supplies. So for our 24 volts, our 15 volts, our negative 15 volts, all these down here are being powered, but the two main rails are not being powered. So let's turn back over to our dim bulb and turn it on. And you can see it's glowing very dim. The camera makes it look brighter than it really is, but I would expect that much right there for the transformers to run and so forth. So our short is gone. Okay, to verify that the bridge rectifiers are not shorted themselves, we're just going to do a simple test. We're going to connect the inputs to them back up to the transformers, since we have our dim bulb, and we're going to just disconnect the outputs of them. Now, if the bridges are shorted, either one of them, the light's going to come on brightly. And again, I'm kind of doing this a little bit slower than I normally would, because I'm kind of following you guys, kind of leading you guys through kind of the thought process. But anyway, they're connected back up. If any of the diodes in here are shorted, you will most likely see the light turn on real bright. So let's plug it back in. And again, we have the outputs, the DC portion of them, disconnected. You can see the wires on both of them are off. So turn this on, and you can see we still have a dim bulb. We don't have a short. So now what we're going to do is each one of these bridge rectifiers, 2 diodes will handle 1/2 of the power supply. So 2 diodes will handle the positive and 2 will handle the negative power supply on these. So we're going to connect one at a time, and we're going to watch our dim bulb until the one that we turn on actually makes the light go bright. Okay, looking down in here, I just have this first one connected. This one is still disconnected, and these other 2 back here are both disconnected. So we only have one leg of one channel. Let's watch our bulb. And what I would expect is when we flip the power on, if that particular node is good, that one capacitor, remember there are 4 big filter capacitors, the one capacitor that's connected to that will charge up, so the light will get a little brighter and then it'll dim back down. So let's see what happens. And there it goes. Did you see it got bright and now dimmed right back down? So that particular side of this amplifier module right here, and that leg of the power supply is good. Let's now connect the other one and see what it does. Okay, we have this one connected in here now, and we're going to plug this back in, repeat our test. Now it should get a little brighter this time because we're charging 2 capacitors, but it still should dim back down once they charge. And did you see that? It got bright and then it dimmed down, and it dimmed to a little brighter level because now we have one of the amp modules powering up. So right now it looks like we don't have any shorts there. So let's go to our next one and see what happens. Alright, and now I've connected this one, which is the positive rail of the other channel, and I still have both of these ones connected. And I'm going to go up to my dim bulb, and we're going to plug it in and do our test again. Now once again, it's going to get a little brighter yet, but it still should flash brighter and then dim down. And did you see it? It flashed brighter and then dimmed down, and now it's getting even dimmer even though the camera's not catching it, and now it's back down to normal level. Now let's connect our last one and see what happens. Okay, our purple wire is connected. Go up here and let's see what we get. Full brightness, no dimness. So that's telling me that that particular side of that amp somewhere in that power supply is shorted. Now we can verify this now that we know which leg it is by disconnecting the other 3, and it should still be bright light like that. So let's disconnect the other 3 again, just leaving the purple wire on, and see what we get. Okay, everything but the purple wire is disconnected, and so we should see a bright light, correct? So let's check it out and let's see what it does. What? So what does that mean? Obviously it didn't do it until we connected that purple wire, but now that it's by itself, the short goes away. So what happens if we hook this orange wire back up, the positive going rail? Let's do that. We're going to leave the other channel disconnected. So this channel here is still going to be out of the picture. This one we're going to connect the two wires. So we'll have positive and negative rail. Okay, they're both connected and the other channel is still disconnected. And as you can see, we're walking on the sun again. So I did this for a reason. I did this to show you that the power supply can be good, and if one rail is turned off and one is on, you won't always see a short that is on the amplifier board. In other words, something else has to turn on for the other thing to show the short, if that makes sense. So the reason I went through so many different steps checking this from every angle is so that we can gather enough information to narrow it down to an area. When we look at the schematic, and remember, I didn't use any fancy tools. I used a light bulb, and I did use a meter a little tiny bit, but so far we've been able to troubleshoot this whole thing by just disconnecting some wires and observing where the short is and what makes the short go away. So if we look here, there's really not much on these big DC rails here. They go out and they go up to here. So even though our transistors don't statically read shorted, somewhere in here we have a short on the one channel. And we have it narrowed to one channel because if I disconnect this side and I reconnect the other side, I don't have that problem. So let me demonstrate that real quick. Okay, now this side here is reconnected. If you notice, everything's all connected back up. This side, I have the purple wire off and I have the orange wire off, so it's disconnected. And let's see the difference now. And you can see it lights up and it dims down. So what that's telling us is that, first of all, one channel appears to be good as far as we know, as far as shorts are concerned. The other channel has a short, and the short has to be somewhere in the output section where your transistors are. So now all we need to do is find out which channel, which one of these boards, okay, because you have two of everything. You have one power board on this side and the other channel power board on this side. We just have to determine from the wires which side this bridge rectifier feeds, and we know that the problem is going to be on that board somewhere. Now, one channel, I totally went through and checked each transistor, pulled them out, put them on a transistor checker, and put them back in. They were all good. So I know that that channel is good. I did then just statically measured the resistance and compared between the two boards, and they seemed to match. So either A, I do have a bad transistor on the other board, or B, there is some other component that's connected across that 86 volts that is shorted that we've not tested. So that's kind of our next step now. Alright, so now I have everything very precariously laid out here on the bench, and all the power supplies are fully connected. The only thing that I've done is I've traced through the wires, and you can see our purple and orange wires coming from that side of the power supply. So this is the bad channel board. The one down here is not bad. All I've done was I separated the board from the driver board. Okay, so we're going, if there's any shorts on this board at all, it'll still light the bulb up brightly. The only thing that's down here is your control circuit and your drivers and so forth. So we just want to see if it changes the problem. So here we go. Let's turn it on. And you can see it dims down. It takes a little while because the capacitors have to charge up, but there we go. So the short is gone. And all I did was unplug. I uncoupled this board from this board. So we need to find what on this board has the 86 volts, plus and minus 86 volts on it, and try to see where it is. I'm suspecting maybe if one of these small signal transistors is shorted or leaking, it's turning on one side of this, either the plus or the minus side of these banks of transistors, and it's putting out DC, and it's causing a short. And it can do that because of the way this thing is put together. So if one side is turned all the way on and the other's not, it'll kind of look like a short. So let's check this down here and see if we have a bad component. Okay, I pulled this board and everything looks good on it. It's in perfect condition. Went through and just kind of statically in circuit tested for shorts. No shorts or anything that I could see on this. I then went back to over here and verified once again everything was good, but there were two components that I missed when I checked this the first time, and they are located here and here, these two diodes. And if you look at them on here, they go right across these transistors. There's two of them, CR43 and CR38. And if we put our meter on diode check and we check our first one, you can see it kind of reads across the capacitors. But if we go across this one, dead short. So we're going to pull that diode and check it out of circuit. And if it is shorted, we're going to replace it. Okay, we have replaced the offending diode. And I put everything back together. And I believe that the reason the short went away when we took the board and decoupled it from the driver board was not because of the driver board, but because this thing actually uses grounding through the chassis. So when we took all of these 8 chassis screws out, we were removing some of the paths to ground, and that's what was removing that short from the power supply. So that was the issue, I think. But anyway, we replaced the diode. You can see over there where we put the new one in. And I don't know, let's see what happens if we still have our bright light or what. It's plugged in. We should be ready. Here we go. Let's see what happens. And there it is. And it's dimming down just fine. Hey. Okay. So it looks now like at least there's no shorts. And we should be able to go ahead now, and before I do anything more, I'm not going to try connecting speakers or anything to it yet. I'm going to actually go into the low voltage power supply, and I'm just going to measure these to make sure, number one, that the voltages are correct, and number two, that there's no ripple, that all the capacitors are okay and everything. I have the feeling that the caps are just fine, but we'll test it just in case, because now we're this far into it. Who wants to have to tear it all back apart again? So we'll check those, and then we'll reassemble. So let's check it out. Okay, right away the first thing I see is that this resistor has been hot, has melted some wire to it, and this capacitor right here is just charbroiled. So I think I'm just going to hedge my bets a little bit and pull this board out and clean it up a little bit and then put it back in before we do much else. But I will do a quick test on the voltages and just to kind of baseline it, make sure that it's at least working first. Okay, I have that capacitor that's cooked on the capacitor analyzer, and if you check for leakage, it'll just sit there all day and just do that. It is extraordinarily leaky. It's just shot, and it's dried out from all that heat. So here's what we did to keep that from ever happening again. So while I was in there, I just replaced all 4 of these caps. So they're all new. And I took this big scorched resistor off of here, and I just kind of remote located it over here with some spacers. And this was a 20 watt ceramic, and this is a 50 watt aluminum body, so it will take the heat a lot more. There's airflow around it so that it can vent some of the heat off, and we shouldn't have that problem anymore. Now, what is this circuit? Well, let's go down to the schematic and look. Okay, hopefully I have this all in frame. If we look down here, if you recall from the Sound Craftsman PM860, I think it's called, video where I restored that Sound Craftsman amplifier, it had the triacs in it as well, soft start circuit and so forth, but it also had a similar circuit to this one. If you look here, your power switch goes not only up to this, and we talked about this for turning on the amp, but it also comes down and goes to this fan right here, and this is the actual fan, the cooling fan for the amplifier. But it goes up through here, and if you notice, there's a triac here as well that is controlled by an opto-isolator. And the opto-isolator is controlled by these power supplies. Now, right here across this, you notice a 250 ohm if it's a domestic made for USA version, and if it's an export version, it's a 400 ohm. And what this is doing is, if this is turned off, current's going to flow through the fan and through the resistor, and this resistor is going to be a dropping resistor to slow the fan down, just like in the Sound Craftsman. As the amplifier heats up, it's going to actually activate this opto-isolator, which is going to gate this triac, and the triac is going to short this out. It's going to act like a switch, like a short, and allow the full power come to the fan, and the fan will turn on full speed. It'll be noisy, but it will also cool the amp. So if you recall, that fan was in some pretty horrible shape, and I took the time and completely cleaned it, and it's working perfectly. And that's good news, because I don't have one of these in stock. I would have to order one, and so I guess there won't be any fan mail today. Sorry, there's some dislikes. Alright guys, so now that we have it all put back together, and I have not tried it yet, let's see if our fan turns and if our little resistor circuit functions. Here we go. And there it is. And the fan is turning. Nice. Okay, we'll do another quick spot check of the voltages, although they were okay when I checked them. And I don't have to do that on camera. That's nothing exciting. If you look at these connectors, there's one set of connectors for each channel, and this is where all your voltages are. So if you go from chassis ground and you go through these pins, you'll see your plus 24, your plus and minus 15, and yeah, 24 and plus and minus 15 on this one, and on this one for the other channel, and that's all we're going to measure then. Everything else looks to be okay, so at this point in the game, I think we're ready to put it back together and see if it actually works. Okay, we're all back together and everything is assembled, and I have my 1000 watt dummy load on each channel, and I just kind of have this thing rigged together real quick. I'm going to put 2 volts RMS into the amplifier, and let's go in on our oscilloscope. Now I have my probe set to times 10, but the scale is on times 1 right now, so actually, even though it's saying 50 volts per division, or 5 volts per division, it's actually 50 volts per division. So if you look on the channel 1, we look at the power output, that'll give you an idea of how many volts RMS we're getting. You could see about 53.9. So that's 53, about 54 volts RMS. So let's check that out. Would be 364.5 watts. So this is putting out about 365 watts per channel. I can drive it a little bit harder into clipping, but that's very clean. As you could see, there was no distortion whatsoever, and that's about normal for this. Remember, this is an 8 ohm load. It can actually do more at 2 ohms and 4 ohms. This is 2 ohms stable, I'm pretty sure. I think it even goes lower than that. But looks like the amp's fixed. We got everything working. And yeah, I don't know what I'm going to do with this thing, but $20 for the amp and 50 cents for the diode, and there's a little bit of elbow grease and some work, and we brought it back to life. So I hope you enjoyed this video. I looked, and there is nothing online about these at all. Very hard to get information on them. So I hope any of you that are servicing these, this helps you out a little bit. I'm pretty sure a lot of the CS series from this era, like the 800, CS-800 and 600 and CS-1000, I think some of them are very similar to this. So servicing them should be similar. But other than that, I hope you enjoyed it. So I know I sure did. So till next time, peace, joy, happiness, and good health in your lives. I wish you all the best. Thank you all for the comments and all the donations and so forth. And until next time, stay well. Bye-bye.